Welcome to the introduction to Web 3.0. Web 3.0, also known as the semantic web, is the next evolution of the internet. It's a vision of a decentralized and open network where users have greater control over their data and are able to interact with each other directly without the need for a middleman. Unlike Web 1.0, which was primarily used to display static information, and Web 2.0, which introduced interactive features and social media, Web 3.0 aims to create a more intelligent and autonomous web where machines and software can understand and interpret the meaning of the data rather than just its structure. One of the key technologies driving the Web 3.0 is blockchain, which enables the creation of decentralized systems that are not controlled by any single entity. This has led to the emergence of new decentralized applications, also known as dApps. That can be built on top of blockchain networks such as Bitcoin and Ethereum and run without the need for a central server. Web 3.0 is about using decentralized technologies and protocols to build distributed systems and decentralized applications. This means using technologies like peer to peer networking and smart contracts to create systems that are not controlled by any single entity. One example of a decentralized application built on Web 3.0 is a decentralized marketplace. This type of dApp would use a blockchain network to create a tamper-proof and transparent record of transactions and smart contracts to facilitate trades between users without the need, again, for a central authority or middleman. Users would interact with the marketplace using a web interface built on top of a blockchain and would be able to securely buy and sell goods and services using cryptocurrency. The decentralized nature of the marketplace would make it resistant to censorship and give users more control over their data and transactions. Another example of dApp in Web 3.0 is a decentralized prediction market where individuals can bet on the outcome of events and the market collectively predicts the likely outcome. The dApps can be built on various blockchains such as Ethereum, EOS, Tron, etc. The steps followed in a typical decentralized marketplace are: step one, the entities submit their data streams. Step two, the marketplace stores, encrypt, and anonymizes the access to the submitted data streams. Step three, the buyer acquires the desired data stream through an automated smart contract. Step four, once the transaction is completed, the tokens are distributed among the parties according to agreed prices. Step five, the marketplace and an underlying data sharing protocol allow for aligned incentives for data owners and suppliers to share data and make it available to others. A starting point would be to create a simple smart contract called simple storage that stores a single unit of type unsigned integer called stored data. The contract has two functions, set and get. The set function takes a single input of type unsigned integer and sets the value of stored data into the input value. The get function returns the current value of the stored data. The first line is called a pragma, and it specifies the version of the Solidity compiler that should be used to compile the contract. On the second line, you'll see the contract definition starts with the keyword contract, followed by the name of the contract, and in this case, it's simple storage. The stored data variable is defined as private, meaning that it can only be accessed by functions within the contract. The set function is defined as public, meaning that it can be called by anyone. It takes a single input of type unsigned integer and sets the value of stored data to the input value. The get function is also defined as public, but it has the additional keyword view, which means that it will not modify the state of the contract. It returns the current value of the stored data. An example of decentralized application built on Web 3.0 from a coding aspect could be a simple decentralized marketplace using the Ethereum blockchain and the Solidity programming language. This smart contract defines a simple marketplace where users can add and purchase items. The add item function allows the owner of the contract to add new items to the marketplace, while the purchase item function allows any user to purchase items using Ether. The smart contract keeps track of the balance of each user using a mapping of addresses to balances and keeps track of the items for sale using a nested mapping of addresses to items. The smart contract also emit events which can be listened to by external DApp or front end. This is a basic example, and one can add more functionality like escrow using ERC20 tokens or creating a decentralized autonomous organization for the management of the marketplace. First, you will need to create a new file and copy the code provided into that file and save it with a .sol extension. Next, you will need to open a terminal and navigate to the directory where the contract file is located. Then you will need to run the Solidity compiler on the contract file. For example, if you are using Sulk, you can run the following command. This will output the binary code in the ABI, which is application binary interface of the contract. Now you need to deploy the contract to your local blockchain network. This can be done using a tool like Truffle or web3.js. Once the contract is deployed, you can interact with it by calling its functions and sending transactions to it. This can be done using a tool like Truffle or Web 3.0 JS, or by using Remix or any other tool that allows you to interact with smart contract deployed on platforms like Ethereum. Please note, this is a high-level overview of the process, and there may be additional steps or variations depending on your specific development environment and tools. There are a few additional steps that may be necessary depending on your specific development setup and tools. There are a few additional steps that may be necessary depending on your specific development setup and tools. Setting up your development environment, you will need to have a local blockchain network setup like Ganache or Geth and a Solidity compiler like Sulk installed on your computer. Installing dependencies would be depending on the tools you are using to interact with the smart contract. You may need to install additional dependencies. For example, if you're using Truffle, you will need to install Truffle and a local test network like Ganache CLI. Migrating the contract calls for migration. Truffle uses migration scripts to deploy contracts to the network. You will need to create a migration script that deploys the contract to your local blockchain network. Before deploying the contract to the mainnet, it's always a good practice to test the contract on a testnet or on a local blockchain network. This can be done by writing test cases for the contract and running them using a testing framework like Truffle or Mocha. Before deploying the contract to the mainnet, it is also a good practice to have a professional security audit done on the contract to ensure that it is secure and free of vulnerabilities. Once you've tested and audited the contract, you can deploy it to the mainnet using a tool like Truffle or Web3.js. Get familiar with the existing platforms, development tools, and community resources that are available for Web 3.0 development. Start experimenting. Once you've learned the basics, start experimenting with building small dApps and contributing to existing open source projects. This will give you hands-on experience and help you understand the practical application of the concepts you've learned. Stay up to date by keeping up with the latest developments and advancements in Web 3.0 by reading relevant news and articles and joining online communities. Also, you may consider joining developer communities such as forums or online groups to interact with other developers and learn from their experience. This can also help you stay up to date with the latest best practices and technologies. Remember that coding for Web 3.0 is still in development and new technologies are emerging, so it's essential to stay up to date with the latest advancements and best practices.